Hello everyone, Dr. Vaughn. I'm going to make a video about this homework from section 11. I'm going to try to do more than one section today. We'll see how it goes, but I want to talk about the different methods for solving a quadratic equation. So we're going to use this one because this one came in by request through email. So we're going to start with that and maybe look at a couple of the other quadratics. And I want to look at 12 in particular. So here I have a quadratic equation, x squared plus 3x minus 1 equals 0. The first thing, I've copied it over to the whiteboard, but the first thing you always want to make sure is everything is over on one side. So you got all this stuff equals 0. So you always want to have equals 0 almost regardless of which kind of a method you're going to use to solve this. So the different methods for solving a quadratic equation are, one, I could try to factor. This one doesn't factor, and it doesn't help you if you have complex roots. You can do the one that we're going to use here. They ask us to complete the square, so we're going to complete the square. So we'll just make a list over here, complete the square. Or in general, you can use the quadratic formula. And I'll talk as we go through some of the different cues. If they don't tell me a specific method to use, handwriting is atrocious. It's hard doing this with a mouse. Okay, so quadratic formula. So for this time, we're going to use this completing the square method. And I might add a method or two onto here if we get to it. So what I do with these is first of all, I just split off. Since there's no number out in front of the x squared, I'm just going to split off the x's from the other term. That is, I'm just going to leave a space. And now I'm thinking about this space right here as being creating that perfect square trinomial. I'm going to take this middle number, call it b if you want. B is equal to 3. And I'm going to divide that number by 2. So in this case, that's 3 halves. And then I'm going to square that b divided by 2. So 3 halves squared, in my case, is 9/4. And that's what I'm going to add in here to make the perfect square trinomial. And then I either have to subtract that number back off, or I have to add the same amount to the other side. I generally like to add the same amount to the other side to keep it in balance. So I added 9/4 here to create the perfect square trinomial, and I added 9/4 to the 0 just to make sure that I still have an equation that things are still equal. Now the three terms here become, in parentheses, x, because I had the leading coefficient of 1, and that half number, which is 3 halves. And you can verify this by foiling it out to make sure that you get that. Then I still had the -1 that was there, and now on the other side I had 0 plus 9/4, which is 9/4. All right, so that's kind of all of that's the hard part, is the creating the perfect square trinomial. That's the completing the square process. The rest of this now is to get the square term by itself. So I'm going to add the 1 to the other side. And getting a common denominator, that's 9/4 plus 4/4, so that's going to be 13/4. And then I have the perfect square trinomial, the x plus 3 halves quantity squared. Now I'm going to move over into this space on the whiteboard here just to finish this off. Now I need to take the square root of both sides. Now the square root of something squared is technically the absolute value. And so the plus or minus doesn't really come from the square root, but it comes from the fact that the square root of the square is the absolute value. But I'm going to just skip that, writing out the absolute value, and go right to square root of both sides. And do square root of 13/4. But I'm going to put the plus or minus, which again comes from that absolute value. And finally, I'm going to subtract 3 halves from both sides. And I'm going to do that out front on the right-hand side. So now I got the x by itself. I get the minus 3 halves that came over from the left, plus or minus. And this square root of 13/4, the square root of 13 is the square root of 13. The square root of 4, though, is 2. So I can write this as square root of 13 all over 2. And these are the answers that I'm going to put right into the Pearson box Now, someone told me this, I didn't know this, but you can either separate these answers by a comma. So I can write negative 3/2 plus square root of 13 over 2, comma, negative 3/2 minus square root of 13 over 2. But you can also write it in one term when it has this plus or minus thing in there. So I'm going to write negative 3/2, and then I'm going to use the plus or minus button, and then do square root of 13 over 2. Make sure that that's the same thing that I had written over here, and then I can check my answer. All right, so there's an example of completing the square. Now, I like to jump up to number 12 because it's going to, well, actually, I'm sorry, let's do number 7 first, because this one has this kind of number out in front of the x squared that's not a 1. And that's going to complicate things a little bit for us in doing this same process. So I'll copy this over onto the whiteboard, and then we'll go from there. 5x squared plus minus 6x and plus 5. So in this case, when I have a number out in front of the x squared, I'm going to start off the same way. That is, separate out the first two terms from the last term. Leave a big space, do the plus 5 equals 0. Really haven't done anything, I'm just setting it up. But now I need to factor out that 5. So I'm going to create this parentheses here, and then I'm still going to have the plus 5 equals 0. But the 5 taken away from the x squared gives me just x squared. And now I'm going to have minus. Now I have to adjust what this number is going to be. So the way I think about this is I'm just dividing by that number, because if I remultiplied, so I'm going to take 6 and I'm going to divide by 5. Because if I remultiplied by 5, I'd be back to just the minus 6 that I started with. Okay, so that's the factoring out process. Now I'm going to look at just this perfect square trinomial part, and I'm going to do the same thing that I did before. That is, I'm going to take this middle number, the minus 6/5, that's b, and I'm going to divide by 2. So that's, times 1/2, if you will. And so I'm going to get minus 6 over 10, which is minus 3 over 5. And now that number, that b divided by 2, gets squared. So that gives me 9 over 25. And that's what gets added here in order to complete the square, the perfect square trinomial. I'm going to add 9 over 25. Now remember, last time we added the same number over here. But this time I'm going to add not quite the same number, because this 9 over 25 gets multiplied by the 5. So 5 times 9 over 25 is what I'm going to add over here to compensate. 5 times 9 over 25, which is actually just 9 over 5. All right, so now I'm going to just clean up this 5 is just sitting there. These three things become that perfect square trinomial, which is x and that half number, which was 3/5. I had the plus 5 here. Didn't do anything with that. And then over here, I got 5 times 9 over 25, which, as I said, was 9 over 5. All right, so now that's why I wanted to do this problem, is to talk about the factoring out process. But from here on out, there's another important thing to realize, and that is if I subtract 5 from both sides to try and isolate this square, I get 5 times x minus 3/5 quantity squared. I get 9 over 5 minus 5 over 1, which is 25 over 5. So 9 minus 25 all over 5. I'm going to get negative 16 over 5. Now, if they only wanted real solutions, I would stop and say, you can't square something and get a negative number. but they actually want imaginary solutions, the I as needed. So I'm going to keep going. I'm going to divide both sides by 5. Okay, let me again move over into this section here. Divide both sides by 5 to get that square term by itself, x minus 3/2 quantity squared. And when I divide by 5, I'm going to get negative 16 over 25. Now I'm going to take the square root of both sides, remembering that's absolute value, but I'm just going to make it a plus or minus on the other side. So x minus 3/2 equals plus or minus the square root of negative 16 over 25. Now every time I see square root negative, that's just going to become an I. And then the square root of 16 over 25 is the square root of 16 over the square root of 5. So that's going to become 4 over 5. Still have the plus or minus, but now I'm going to move this 3/2 over to the other side. And I put that out front because it's the real part. And that 4/5 I was the imaginary part. And this is the answer that I'm going to put over into my box. 3/2 plus or minus 4/5 over I. Again, they'll let me use that plus or minus button. I need to make sure, though, that the I is not in the denominator. You can put it in the numerator, but you can't have 4 over 5I. You have to have 4/5 times I. And it looks like I made a mistake somewhere. Oh my. Well, I make mistakes all the time. So let's see what happened. Oh, it was 3/5, not 3/2. Look at this. It was 3/5 and I suddenly made it 3/2. So let's go through and just fix that. And then just make the correction over here. 3/5 plus or minus 4/5 I. Okay, that looks better. All right, I think we have time for one more. I'm going to look at question 12. This one's more of a geometry problem. I got a ladder leaning against the building with the base of the ladder is 3 feet from the building. How high will the top of the ladder reach? All right, I'm going to clear this out. You can always go back and rewind the video. If you missed something, take a screenshot of it, whatever. So 15-foot ladder. Here's the building. The base of the ladder is 3 feet out. The ladder itself is 15 feet long. Seems to me like this is a pretty much a Pythagorean theorem kind of question. How high up on the building? And so 3 squared plus x squared, let's call it, equals 15 squared. Well, let me just call this x. All right, so by Pythagorean theorem, 3 squared plus x squared equals 15 squared. So I'm going to take x squared is 15 squared minus not 3 squared, which is 9. So x squared is equal to, let's see, 15 squared, what's that, 225? Minus 9 is 216. So I'm going to take the square root, and again you'd get plus or minus the square root of 216, but of course it can't be negative because it doesn't make sense in the context of this problem. And they want me to type an exact answer using radicals, and they want me to simplify. So let's just look at this square root of 216 now and simplify that, if possible, as a radical. So what I'm trying to do now is pull out any perfect squares from the 216. So I'm going to do a prime factor tree over here. That's 2 times 108, which is 2 times 54. 54 is 2 times 27. And 27 is 3 times 3 times 3. Okay, so it's 2 times 2 times 2 times 3 times 3 times 3, 2 cubed times 3 cubed. But what I'm looking for is pairs because I'm doing a square root. So here's 2 2s and 1 2 left over, and here's 2 3s and 1 3 left over. So when I go to simplify this radical, these 2 2s, the 4, is going to come out and become 1 2 outside of the radical. These 2 3s inside are going to become 1 3 outside. And then I have the square root, and I have the leftover pieces, which is this 2 and the 3, and that's a 6. So I'm going to get 6 times the square root of 6 as the simplified radical. And that's what I'm going to type over here into the box. Now, I think there's another part. So how far will the ladder reach up high on the building? Seems like the same question. What happened? Is there a second part to this? Oh, now it wants round to the nearest tenth. Same question, but they want this to be calculated. So now I'll just pull up my calculator. And I'll do clear 6 times, and on this calculator, I have to do let's see, where's that? Oh, yeah. Okay, 6 and then second the square to get the square root function and then equal. You can kind of see right up here, 6 times the square root of 6. So you have 14.6969, and they want this rounded to the nearest tenth. The tenth is the 6, so I'm going to round that up to 14.7. All right, so this video is getting a little long, so I think I'm going to sign out at this point, and then maybe later today I'll try to do one of these videos for 11.2. Or if there's another question from 11.1 that you need help with, send me an email, text me, call me, hop onto my Zoom session. I think the links are posted up in the announcement. I'm online for you 8 hours a day, 7 days a week, and I'd love to talk to you about this. All right, this is Dr. Vaughn signing off. Talk to you next time. Bye.